Welcome to the Podkey summary of Create Robust Evaluations for Agentic Apps from WWDC 2026. A lot of this comes down to a simple idea. If you're testing AI with a tiny dataset, you can talk yourself into thinking things work better than they actually do. The big themes here are synthetic data generation, how to judge coverage instead of chasing a magic sample count, and how to evaluate tool-using models in a way that actually catches workflow mistakes. There are also some very practical details underneath all that, like session setup, context limits, validators, sampling strategy, and why a score dropping can actually be useful news. The synthetic data workflow is built around an async stream through a MakeSamples API. And the nice part is that it feels iterative rather than one and done. You start with a small seed dataset, generate more examples from it, validate what comes back, and then keep going until the dataset feels like it actually reflects the real variety you're likely to see. That framing matters, because the goal isn't to conjure fake data for the sake of volume. It's to use synthetic examples to widen the picture you get from a limited set of real ones. One little detail that helps make the workflow concrete. The target count includes your original seed examples. So if you ask for 100 total samples and you already have 13 seeds, the system generates 87 new ones. It's blending the handmade examples with the synthetic expansion, not replacing them. The strongest point in all of this is probably the simplest one. Sample count by itself is a weak question. The better question is whether you've covered the meaningful variety of real-world inputs. They give a very relatable example with book reviews. If you evaluate on 13 carefully handcrafted reviews, your tag generation quality can look great. Then you expand that set to 100 more diverse reviews, and suddenly the score drops. Same system, same task, very different picture. That doesn't mean the larger dataset is mean. It means the smaller one was flattering. And honestly, that's a useful correction. A compact set can be clean and convenient, but if it doesn't include the weird phrasing, mixed tones, edge cases, and plain messy reality people actually produce, it's not telling you much. When scores fall after you broaden the dataset, that's not automatically bad news. It can be the first honest signal you've gotten. A drop like that can point to prompt issues, instruction tuning problems, limitations in the underlying intelligence feature, or just the fact that your earlier dataset wasn't representative enough. In other words, the score decline isn't the story by itself. The story is what it reveals. That turns evaluation into a loop too. Expand coverage, rerun tests, find hidden weaknesses, tighten the system, and repeat. There are also a couple of practical knobs for how synthetic samples get generated. One is random sampling, which is the default. It picks a non-deterministic subset of seed examples. And that's usually fine when the order of your seeds doesn't mean anything. The other is sliding window, which moves through the seeds sequentially. That's the one to use when the seed set has some intentional ordering built into it. Then there's validation. You can provide a validator closure that accepts or rejects each generated sample based on rules you define. So if you're working with reviews, you might require a minimum review length, a certain number of tags, or that tags stay lowercase. That kind of structural filtering is great for automating quality control. It catches obvious junk without making you eyeball every sample. But it also has limits. If you're trying to judge something holistic, like whether you've got enough genre diversity across the whole set, a validator looking at one sample at a time can't really settle that for you. At some point, human judgment still has to step in and say, yeah, this dataset actually feels balanced, or no, it's still weirdly clustered. On the model side, developers can supply a session, provide a closure that returns a language model session. So you're choosing the model and the system instructions explicitly. That means you can do things like use a private cloud, compute language model, and shape the session behavior up front. One especially important caveat is what happens when the context window gets exceeded in the middle of generation. The framework will automatically create a fresh session and keep going, which sounds helpful, and it is, but it also means your prompts need to be self-contained. You can't assume the model will remember earlier context if a reset happens under the hood. Batch size gets handled automatically, but you can still run into context window errors if prompts or outputs get too large. So this is one of those places where careful prompt design saves you from mysterious pain later. The other major thread here is tool call evaluation, and this is where trajectory expectations come in. A trajectory expectation defines the sequence of tool calls and arguments you expect to see in the model's transcript. The travel itinerary comparison is pretty apt. You're not just checking whether the model eventually arrived somewhere useful. You're checking whether it took the right route. These expectations can be unordered, meaning the call can appear anywhere in the session, or ordered, meaning the exact sequence matters. And for multi-tool workflows, sequence matters a lot. If a model calls get book details before search books, that's a bug, because it doesn't have the book ID yet. Trajectory expectations let you catch that kind of logic failure directly, instead of pretending the outcome was close enough. The argument matching side is flexible too. You can use matchers like natural language, contains, one of, pattern, and range. That keeps the evaluation from being too brittle. If the model searches for something described as uplifting or happy, when the expected idea was cheerful, you don't have to fail it over wording trivia. And just like regular evaluation data, tool evaluation datasets can also be synthesized. You mark model sample and trajectory expectation as generable and feed them into the sample generator. The important catch is that the prompt has to explicitly describe the available tools, what each one does, and any ordering constraints. The model doesn't magically know your app's tool belt. If you want good synthetic tool use examples, you have to spell out the world you're asking it to operate in. The through line in all of this is pretty grounded. Build tests that reflect reality, make prompts robust enough to survive the actual mechanics of generation, and evaluate workflows in a way that catches real mistakes. If your score gets worse after you do that, annoying, sure, but also kind of perfect. Better to learn it from your dataset than from your users. This episode was generated by Podkey. Create your own at podkey.fm.